Hello guys, today we're going to be discussing fluid flow continuity. Fluid flow continuity is primarily based on the equation of continuity. The equation of continuity, if a fluid enters one end of a pipe, it must exit through that same pipe regardless of the area change. Basically, the equation states what goes in must come out. The mass flow rate can be expressed as delta m over delta t, being the change in mass divided by the change in time. Since the mass flow rate is constant, the mass flow rate at any one point along the pipe or tube can be set equal to any other point along that same pipe or tube. So here you can see that the larger the cross-sectional area of a pipe or tube is, the smaller the velocity will be of that fluid, and vice versa. If a fluid is incompressible, this means that the density does not change, so the same fluid that's entering the pipe must be the same fluid leaving. This video demonstrates volume flow rate.
In this screencast, we're going to talk about the relationship between mass flow rate, volumetric flow rate, and density. Is defined as, in this case, the mass flow rate over the volumetric flow rate. So you can see that there's a relationship between the three of them. The volumetric flow rate equals the mass flow rate over density, and the mass flow rate equals rho times V. And the important thing to remember is the density can change from inlet to outlet. The volumetric flow rate can change from inlet to outlet, but this is constant when our mass balance is E in equals E out. So let's take a look at some examples. If we have a cone-shaped pipe like this, and we have flow in and flow out, the mass flow at the inlet has to equal the mass flow at the outlet. Now, let's say we have a gas at constant density. What can we say about the volumetric flow rate going in and the volumetric flow rate going out? Well, if the density is constant and we know that the mass flow rate is constant, then the volumetric flow rate is constant. So the volumetric flow rate at the inlet has to equal the volumetric flow rate at the outlet. This again is only if it's at constant density. Now, let's look at a situation where constant density. So let's say that the density of a gas decreases from the inlet to the outlet. In other words, the density going in is greater than the density coming out. Well, we know that the mass flow rate stays constant, so rho in V in has to equal rho out V out. However, if rho in is greater than rho out, in order for the mass balance to work, V in has to be less than V